This isn't a very long lecture, but we're looking at hard disk maintenance. A lot of people, they buy a new machine, they use it for a while, and the machine seems to get slower and slower and slower, and it's really frustrating. One of the things that could be slowing down your computer is your hard drive. It's not that it's spinning slower, it's just getting disorganized. A lot of people think, I got a slow machine, I need to get a faster processor. And the answer typically is no, you don't. What you need is a hard drive that's functioning correctly. Before saying, hey, this computer runs slowly because of the processor or the lack of memory, most often the reason you have a slow computer is because of the hard drive. So you want to check this first when you're trying to figure out what's going on with the computer. I see so many people going out and buying more memory when the problem is the hard drive. Luckily, it's really easy to fix. It's not like a hardware fix, it's a software fix. So neglecting your hard drive, you get slow performance, you get system crashes, you lose data. That's the worst thing. You know, if you don't take care of the drive properly, it's gonna fail on you someday. Now, all hard drives fail. You should have a backup of it somehow. For me at home, I have a portable hard drive that I plug into like a USB 3.0 port, and I just do a backup onto that. Do that every couple weeks or so. It depends on how important your data is to you. A lot of the data now is out in the cloud. So do you have to do backups? Not really. It'd be nice though if, say, Google's servers explode, you'd have local copies of those same files. In Google Drive, you can have it set up so it syncs with the folders on your machine. So you can copy files just like you would with any other folder on your machine, and it would automatically copy it out to Google Drive. That's kind of neat. But for me, I still have a lot of data I don't want to lose, basically curriculum stuff or programs I'm working on or music that I write. I write a lot of music. Kind of had a fun gig over the weekend. I got to play bass with piano player for Stevie Wonder's group. So that was cool. That's my alter ego. When I'm not teaching computer science, I'm usually playing music. Windows doesn't write a file into the disk in one large block. It breaks it up into smaller pieces. It tries to write them close together, but sometimes it can't. Okay, so let's take a look at that. I'll make a little graphic here on the board. Suppose this is your hard disk. Looks like this. This is one of the platters. And your disk is kind of separated into sectors, kind of like a pizza. And this is a really rough description how sectors work, but for visuals it works pretty well. Now somewhere in your computer there's a file1.txt file. Okay? And it points to that location where file 1 starts. So maybe this is the starting location, and then it goes to the next sector. So that's called an allocation unit. The smallest file you can ever have is 1 allocation unit. How much memory is that? A lot of disks, that's about 4,000 kilobytes, so not very big. Say there's more to the file though than 4,000 kilobytes. What it will do is it will, if the next section is free when it's writing it, it will take this end of sector pointer and point to the next sector and then go here. And that's the most efficient way because, you know, it spins underneath the read-write heads and the next sector is part of the same file. So that's good. That little actuator arm doesn't have to move that much. But say the next part of this file is over here. So this one points to that one. That's not great because not only is it not on the same track, it's also has to wait for this section to spin underneath the drive head another time. It can't read two tracks at once. So this is a problem. And if your disk is fragmented, and that's what we're talking about here, the files are scattered all over the disk where it's jumping all over to actually read the files. So here's the hard drive, the little actuator arm. This is what moves the read and write head back and forth, kind of like a record player. And as it moves, it's changing to different tracks. And so I'm suggesting on our chart there that, hey, the first file is right there and it spins a little bit and sees the next part of the files on the next same track. But then it has to move the read-write head and keep spinning until it gets to the part where the next part of the file is under that. What this is the file is fragmented because it isn't in one circle or one cylinder on the disk. So when a file is written to disk, it actually is written in pieces. It's chopped up into 4,096 byte chunks, and it writes them sector by sector. Now, if your disk is really full and there's not a lot of sectors that are contiguous, meaning right next to each other, then it has to scatter the file all over the disk. It just shreds the file and puts it on all these different open Swiss cheese spots, just trying to find space. And so what happens is your disk is constantly moving the actuator heads, which slows it down, and it has to wait. There's two things that make computer hard disks work poorly. It's called seek time. How long does it take to get the actuator arm to the right track? Just because you're on the right track doesn't mean you're done. Now you have to wait for that data that you want to come underneath the read and write head. So that's called latency time. If your files are fragmented all over the disk, that seek time is going to take a lot of time because it's always moving when it's reading just one single file. And then once it gets to the right track, it has to wait until that comes underneath. So the more fragmented your disk is, the slower your machine seems to go. Now, if you're one of those people that keeps their hard disk pretty full, you're going to have this problem all the time because there's not a lot of space. There's only tiny little holes. So when you write new files, it'll just scatter them across the disk. And then your disk becomes completely fragmented and it slows down. Now, the operating system tries to write the files close together, but it's not always able to do that. So as the drive fills up, now it becomes harder and harder to keep the files together. The pieces get spread all across the disk, and disk performance degrades considerably. Now, how many people in this class have ever defragmented their hard drive on their machine at home? A few, one, two. Yeah, not a lot of people do that. My guess is if you try this at home, you'll find that your disk is horribly fragmented, and you'll need to run a defragmentation utility. And it's just like having a new computer. As soon as you do that, your computer is really fast now. There's some tools that come with Windows that help keep your hard drive working like a champ. So we're going to take a look at some of them. So what a disk defragmenter does is it locates the fragmented files and moves the pieces of the files so they're all in one big long line on the same track of the disk. Or when should you defragment? When the disk fragmentation is greater than 5%. 10% for certainly, but 5% is good as well. So not a lot of fragmentation, but if you run the defragmenter and it's 5% fragmentation, you should see a small increase in performance. You never lose any data when you defragment. It keeps a copy of it while it's doing the defragmenting. If you yank the cable while it's defragmented, do you lose all your data? And the answer is no. It does it in very discrete steps so that you can pull the plug. I wouldn't recommend it, but you should be able to pull the plug and still have all your files there. Yeah.
So what happens if your disk is like below 50?
50, then yeah, you really need to run it. But you also have to leave it space for the defragmenter. If your disk is almost full and it's fragmented, if you only have like 2K of disk space left, it's going to take you 20 years to defragment the disk. You got to give the defragmenter some room to make those copies. So a lot of people say, well, how do you find the tool? I'm going to show you how to do that. Like, open up the file folder and right click on this PC and then say properties. Yeah, properties isn't where it's at. You actually go to the drive you want to go. You want to defrag. So go directly to the C drive, right click and say properties. There it is. And it shows you the capacity of the hard disk. This is about 500 gigabytes. It has ways of cleaning up the disk, gets rid of temporary files. But the one I'm looking at is this one. We want to do a defragmentation on it. Let's first do the defragmentation. We'd like to analyze the disk to see how fragmented it is. So you have to be an administrator to do this. If you're not an administrator, it'll probably do the analysis, but it won't let you actually do the defragmentation. So it's analyzing it right now, and it sees that the drive is 2% fragmented, which isn't high enough to actually warrant doing a defragmentation. Say you're ready to try it. Say I still want to defragment. I say optimize, and it starts the defragmentation. So there's a few files that are fragmented. It's going through and lining those files up on another part of the disk. Yeah. Yeah. So that little magnet's going on and off super fast to write the ones and zeros. Now, if you have lots of fragmented files, this could take all night or even longer, depending on how much disk space you have. Can you stop the process in the middle? Yeah, you can. You can also set this up so that you can say how frequently you want to run the defragmenter. So you can put it on a schedule. And by default, I think the newer versions of Windows allow you to do that. So yours might be a lot better than you might think. So again, if a lot of the installs of Windows now have defragmentation turned on. So I'm about 50% done. Okay, so I'm going to stop it right now. You can stop in the middle and not hurt anything. So. Now, another thing you should do, you won't be able to actually defragment the disk unless you do this other thing first if there's errors. It's called the check this drive. I say check. And the problem is it can't do that because the drive is currently being used for the operating system. Here it says, we haven't found any errors on this drive. You can still scan for errors if you want. So keep using the drive during the scan. If errors are found, you can decide if you want to fix them. So it's scanning the drive to see if there's any file problems or bad sectors. So that would be the one I would do first. And here it's looking for file errors. It might be looking for bad sectors on a file. It'll take those sectors, hopefully, and mark them as bad on the hard disk. Just because your disk has bad sectors doesn't mean you should chuck your computer or chuck the hard disk. A lot of drives have lots of bad sectors and they still work just fine. All the operating system does is mark that sector as bad, and then from that point forward it never gets used to store any files. Okay, so going back to the slides then. Right now the tool we're using is check disk. So that's the one. That's what's going on right now. Let's see if I can see the window. Yeah. So we're doing a check disk right now. It's just checking the file system, making sure the disk is functioning physically, that ones can be written, zeros can be written. This is taking a while though. But say your disk does have problems, you can't run check disk right now. What you can do is you can schedule the next time the computer boots up, it will run check disk and try to fix those errors. Right now it's just scanning, but it's not fixing the errors. Okay, it can't do that unless the hard drive's not being used right now. So there's this little flag you say, hey, the next time we reboot the computer, run check disk first before you load the operating system, and it will do that for you. So what does check disk finds and fix? First thing would be cross-linked files. Bad sectors, lost chains. So what's a cross-linked file? If you have two files that are pointing to the same track in the same place, that's bad. Yeah, that means your pointers are messed up. You've got two different files pointing at the same, and then from that point forward they get the same half of the file. So if you have that in your hard drive, that's a really big problem. So the check disk fixes that problem. Bad sectors, scans for bad sectors and marks them as bad so that they will no longer be used. Now lost file chains, this is another one that's really kind of cool. Say you have a really big file and for some reason the operating system loses track of the directory entry of it. So the file is still on your disk, but the problem is there's no way to delete it because it's not in your file system. So you've got this like 4 gigabyte file just sitting there wasting space on your disk. You can't get to it anyway. That's called a lost chain. You got this whole big long chain of sectors and there's no way to delete it. Yeah. Yeah, it's really frustrating. Well, this allows you to do that. What it does is it finds those lost chains, it puts it in the file system, and might call it file001.check. You can look at it and you can try to recover it if you know what file it was, but most probably you just want to delete those lost chains. So it creates a file entry for it so that you can delete it later. Yeah. Yeah. Let's go check the status then of our check disk. Windows successfully scanned the drive. There's no errors were found. So there was no lost chains. There was no cross-link files. Yeah, so here's the output from the check disk function. I'm always surprised how many files are on a machine. How many files are on this machine? 500,000. 500,000 files are on this machine. And there's nothing really on these machines other than some software. There's hardly any data. Can you imagine that? How you got here, there's a little place where it says show details. Once you've run check disk, there's a little thing that you can click on. You can see. So it examines the basic file structure, the file name linkage, the security description, scan the entire system. No problems. And that's what I would expect in here. But I bet you if you go home and run check disk on your home computer, you're going to find a few things. And don't freak out. There's going to be bad sectors perhaps. But that's what check disk is for, so you can label those as bad so they won't be used anymore. When about 10 or 15% of your drive is labeled as bad, I would get another drive. Okay. But if it's just a few percentages of your drive, no big deal. Okay. Still do your backups, but. And one thing I do want you to write down is that in order for you to defragment, you have to run check disk first and get rid of all of those errors before you can defragment. The defragmenter won't work if there's file errors in your file system. The way you have to do it is you have to do check disk first. If there isn't any problems, then do the defragmentation. If there is problems like cross-link files or lost chains, you've got to deal with those first, because when defragmenter tries to start, it can't because of those file errors. Run check disk first, remove those errors, and then do the other one. Now, if I really want to run check disk again, and you want to fix those errors, you can't do that while you're running the operating system. And it'll say, hey, do you want to schedule this for the next time the computer restarts? And there you would say yes. Now again, I would recommend doing this when you get home. You'll find a lot of interesting stuff. In fact, that's our assignment. So let's look at our assignment then. Basically, the idea is this. On your home PC, what I'd like you to do is first run check disk and just put it in scan mode, not the fix the problem mode. You just want to see if there's any file system errors on your machine. How do you get there? Well, like we did, right click on the drive itself. So right here. So go on your home machine, pick one of the hard drives, right click on it, and say Properties, Tools, and run that. Now you have to have administrator privileges on the machine to actually change or fix any of the problems. So if your dad or mom is in charge of the machine and you're only a user, you won't be able to do this. But you might have them do it along with you, see if you can speed up your computer. So first run check disk, and what your assignment is to write down what messages came back from check disk. If everything was hunky-dory, then write down what it said on the screen. If there was problems found, that's an important one. Write down what check disk reports back to you. Okay? If you don't have a PC at home, you can run the program here. My guess is these are being defragmented once a week. There's probably nothing wrong with the disk. We might find something. So you can do it now on these machines, but I prefer you would do it at home on your machine. See if you can make your machine work a little bit better. So first run check disk and write down anything it reports back. You might take a video of it because it goes by pretty fast with your phone if you have that. Otherwise, you can go into the event viewer like I did and see the actual report. And again, every version of Windows is a little different. If you're running Linux or Mac, not sure how to do that, but I'm sure Linux has a similar utility. Once check disk is done, then analyze the disk for disk fragmentation. Write down the amount of fragmentation you have, and only initiate the defragmenter to actually defragment the disk if it's greater than 5%.